Welcome. Today we're going to go ahead and look at this problem and self-test of our text, page 183. How many barrels will the cylindrical tank with two half-spherical ends in the sketch below hold? So I'm going to go ahead and work through this whole problem step by step, and let's go ahead and get it. So first thing we want to do is recognize the shape here. So we have, notice, two half spherical ends. And notice also that those two half spherical ends have the same radius, which means if we combine them, it's going to be a single sphere with a radius of 7. So that's the first thing I want to show, that if we have, notice, we have a half a sphere, which means the half of a volume of a sphere. And then we have over here another half a sphere. Since it has the same radius, we can go ahead and add that together, and we're going to have a volume of a single sphere with a radius of 7. Now right here in the middle, we see we have just basically a cylinder. And so we can go ahead and add the volume of a cylinder to that. And so we basically have the volume of a sphere plus the volume of a cylinder. Now let's go ahead and look at our formulas for this. So our formulas for this, notice, volume of a sphere is going to be 4/3 times pi r cubed. And our volume for a cylinder is going to be the base times the height. But in this case, our base happens to be, since it's circular, pi r squared. So I basically have here 4/3 pi r cubed plus pi r squared times height. So this right here, this particular formula, is going to give us the volume of the whole shape, or I should say the volume of our tank. So let's go ahead and find what those things are that we need. Label our radius, label our height. So we notice that the radius for the half spherical shapes are going to be the same as the radius for that cylinder. That is, half of this diameter is 7 as well. So we know that our radius is 7, and we know that our height of that cylinder is going to be, notice, 28. So we're going to go ahead and plug that directly into our formula. So that is going to give us, notice, whenever we figure out what we have here, our volume of the tank is going to be 4/3 times, in place of pi, we can go ahead and put 3.1416 times our radius cubed plus, we have once again pi, so 3.1416 times our radius square times our height, which is 28. Now we go ahead and calculate what this value is. And when we calculate this value, since notice this was in feet, that's in feet, so both radius is in feet, height's in feet, we're going to get cubic feet here for our volume, for our unit of our volume. And when you plug that in, figure out what you get, you have 5,747.0336 Now, we know that, and of course, let me note first before I move on, that's cubic feet. We know that 1 barrel equals 5.61 cubic feet. So if we want to go ahead and convert that to barrels, notice since we're going backwards with the conversion, we're going from cubic feet to barrel as opposed to barrel to cubic feet. So we're going to, instead of multiply, we're going to divide by 5.61 to our measure, our value we have here in cubic feet. So that means we're going to have 5,747.0336 divided by 5.61. That is now going to be in barrels, and we get 1,024 point, when you round to the nearest 100, 43 barrels. All right, so we can hold, that means in this particular cylindrical tank with 2 half spherical ends, we can hold whatever liquid, most probably oil or some type of oil-based fuel. We can hold 1,024.43 barrels. All right, so I hope you enjoyed the problem. Thank you for joining me. You have a wonderful day.